Bismillahirrahmanirrahim. We have to prove this equation. This curl of curl A is equal to minus nebula square A plus gradient of divergence of A. So curl of curl A is equal to curl of determinant. The determinant is I, J in K, and partial by partial X, partial by partial Y, partial by partial Z, A1, A2 or A3. So we have to evaluate this in determine first. This is curl of A. So curl and I partial by partial Y of A3 minus partial by partial Z of A2, then we have plus sign J, partial by partial Z partial by partial Z of A1 minus partial by partial X of A3 and plus K partial by partial X of A2 and minus partial by partial Y of A1 and close the bracket. So curl of this vector, now we have another determinant that is equal to determinant in I, J and K, and then partial by partial X, partial by partial Y, partial by partial Z, and this vector, the first component is partial by partial Y, partial by partial Y, A3 minus partial by partial Z, A2, then partial by partial Z, A1 minus partial by partial X, A3, and the third component is partial by partial X, A2 minus partial by partial Y, A1, and we have to take the determinant. Okay, now I, so in the I direction we have, you see, partial by partial y in this one, so that is partial by partial y, partial by partial x of a2 minus partial by partial y a1 minus z partial by partial z of this component, this one. This is partial by partial z1 and this is 3, this is 3. Okay, so okay, partial by partial z of partial by partial z a1 minus partial by partial x a3. So that is the I component. Then we have to write a little bit here. Plus j and then partial by partial z on this one, that is partial by partial y a3 minus partial by partial z a2. And here is a negative sign, partial by partial x partial by partial x on this component, that is partial a2 by partial x minus partial a1 by partial y. So that is for the j. Now we left with k. So plus k direction, and this is partial by partial x, partial by partial x on this component, that is partial a1 by partial z minus partial a3 by partial x, and minus partial by partial y partial by partial y of, this is operator on this one, so that is partial a3 by partial y and minus partial a2 by partial z. And that's all for the k. Now we see that there are 2 and 2, 4 and 4 and 4, 12 terms. So we have to rearrange the terms. So first I will take two component for the I1. You see partial in the I direction. So I direction partial, there is a negative sign, so I am taking the negative one. Partial square A1 partial y square, and then I will take minus partial square A1 partial z square. So this is, I take two terms of I and two term left, so I am writing the two I terms here. That is partial square A2 partial square A2 partial y partial x partial y partial x plus partial square A3, this is 3a, and partial z and partial x. So these are the four terms of I. So I did for I. Now I will move toward j plus j. So similar terms for j with a negative sign. So I will take this one first, that is minus partial square A2 partial z square and minus partial square A2 partial x square, and the remaining two alongside j. That is partial square A3 partial square A3 partial z and partial y. Another term partial square A1 partial square A1 partial x partial y partial x partial y. So I write four terms of j. Now four terms of k plus k so first this one term 3 A3 terms, so minus partial square A3 and partial square A3 partial x square minus partial square a3 partial y square. Partial y square in two term more plus k partial square a1 partial x and z partial x and partial z plus partial square a2 partial okay, this is partial y and partial z. Okay, so we see you see there are 6 term of this type and 6 term of mix type. So there is a deficiency of partial square a1 partial x square in this one, and a deficiency of partial square a2 partial y square in this one, and partial square a3 by partial square a and z square in this one. So we have to add these terms in these expressions. So I minus partial square a1 partial x square and minus partial square a2 partial y square minus partial square, oh this is 1 partial z square. So this term I subtract this term because it was not in its place, so I will add this one partial square a1 partial x square to annihilate the effect of this one, and the other two terms are partial square a2 partial x and partial y and partial square a3 partial x partial z. Similarly for the j1, this is minus partial square a2 partial x square. I am writing partial square a2 partial square a2 partial y square and minus partial square a2 partial z square. I subtracted this one, so I will add this in the lower one. Partial square a1 partial x partial y and partial square a2 partial y square plus partial square a3 partial y partial z, and then the similarly for the k, this will be partial square with a negative sign a3 partial x square minus partial square a3 partial y square. So I will subtract a partial square a3 partial z square over here. So this is extra term. I will add in the lower line. So here we have partial square a1 partial x partial z plus partial square a2 partial y partial z, and I will add this term in here partial square a3 partial z square. So you see what we did in the previous slide, this term were absent, so we subtracted and added. Here this term were absent, we subtracted and added, and here this term were absent, so we subtracted and added. Why we did it? In fact, we are going to find curl of A so this whole expression is this value. Now what is common in the first line? That is this one. You see, partial by partial x square, partial by partial y square, partial by partial z square, here, here and here. So that is common. So I will take common this one, minus partial square partial z square, x square first, then minus partial square partial y square and minus partial. So I take the minus out, this will become plus partial z square. So everywhere is this operator. So here I left with a1 I, here I left with a2j, and here I left with a3k. So that is the whole upper line I write in these two terms. Now for the lower one, you see what is common over here. So that is partial by partial x, partial by partial x, partial by partial x. So I will take common plus partial by partial x is common with I. So what left inside the bracket? That is partial a1 partial x plus partial a2 partial y partial a3 partial z. That is this first term. Now what is the second one? Plus j o, and what is common over here? That is partial by partial y, and what is left with? Partial a1 partial x plus partial a2 partial y and partial a3 partial z, and the last one, partial by partial z, is common in the k direction. Okay, so what is left with? That is partial a1 partial x partial a2 partial y and partial a3 partial z. So that is equal to, you see what is this? This one, that is nebula square. So negative nebula square me, and this is vector A. Okay. What is common? You see the inside the bracket thing is common in all the three. So what left with? That is partial by partial x I, partial by partial y j, partial by partial z k, and that partial a1 partial x partial a2 partial y partial a3 partial z. You see this is minus nebula square A, this is gradient, and inside the bracket I have let me write it. This is partial by partial x I, partial by partial y j, and partial by partial z k vector, and dot with a1i, a2j, and a3 grade. Okay, curl of curl A is equal to this term. This is minus nebula square vector A and plus gradient inside the bracket. This is the divergence of vector A. So this we proved this assertion. It is an important assertion we use in many applications. So let's discuss a little bit more. You see, this is curl of curl A, and it is equal to minus nebula square A vector and plus gradient of divergence del operator, del dot del, that is nebula square. So if I, instead of curl of A, I put 3 vector over here. So let's say A cross B cross C. There are 3 vectors. If you are interested in this vector triple product, I will follow this rule. You see, the first one is gradient dot del operator dot del operator A, and the second one is clear, the gradient of the divergence of A. So you see, when you take the first two in dot, leaving the third one, so that give me a negative sign. So here is a negative sign, A dot B in C direction, and this is the first and the third. The first is the gradient and the third is A. So the first dot the third, that mean A dot C, and this the vector triple product. The vector triple product, this is to determine, we have to evaluate. If the vector is of high dimension, then it is very difficult to find. Let's say a vector is of 4 dimension. So this will be a 4 by 4 determinant one, and then once we get this vector, then another 4 by 4 determinant. That is very difficult to find. On the right side, it is very easy. Take the dot product of AB and multiply with the vector C, and then take the dot product of A and C, multiply with vector B. That will give me the whole thing. So it is very easy to calculate the vector triple product by this formula. Okay.